Okay, welcome everyone. This is the week 2 webinar of the online statistics class. And I just want to let you know, it's not actually, it won't be that hard to follow what I'm talking about today, but a lot of people do have the most trouble of all weeks when it comes to doing the homework because it's probability, and for some reason, probability is a tough one for people. So just want to give you a heads up that this might be a difficult week, and but I do have a lot to talk about, and I want to make sure that we're all set up. So I'll always start out with Q&A if you have any questions. Always happy to answer them. Always have one eye on the chat box and the other eye on whatever I'm typing. And then what we're going to do after that is I'm going to talk about probability. So we're going to look at the definition of probability. What does it mean to say this is the probability of something, and how do you find a probability? So we're going to look at lots of examples. One cool thing, and well, you know it if you live in Tahoe, is that one of our main industries is gambling, and that's literally all about probability. Okay, and I'll show you some of that stuff. And the other thing is, what do you think? Do you think this is a good time to play the lottery? Do you think the chances of winning are really good? Or do you think the chances of winning are pretty low? And what we'll do is we'll look to see what is the probability of winning a lottery. And I'll even let you pick which lottery to find the probability of, and we'll see. And then I know these look really easy, the word and. It's an important word, and it's a really important in probability. And we'll talk about the probability of the event A and the event B occurring. Then we'll look at the word or. That's the probability of the word A or B occurring. Then we'll look at the word given, and that is the probability that A occurs given that you know B already occurred. Then we'll look at what's called mutually exclusive events. So a little vocabulary, and we'll talk about that when we get there. And we'll also look at independent events. How do you determine if two events are mutually exclusive? And how do you determine if two events are independent? So that's pretty much chapter 3. And again, very important to get chapter 3, but it is, a tough chapter. So I want to give you kind of a heads up. Then what I want to do is go over project 1. So we talked last week in orientation that there was a project, and I see many of you have found partners, which is great. And if you haven't found a partner, you need to find a partner right away, because pretty soon everyone will have found partners and you'll be alone, and alone is not allowed. So you do want to find partners, and remember that's a project discussion board is the best way to find partners. That's a good thing to do. And a lot of people have posted it already and found partners, which is great. And again, recommendation of 3. But today, what I'm going to talk about are all of the different things you should be doing for project 1. Okay, so I'm going to give you a timeline. I'm going to give you kind of the items that you need to put into top project 1, strategies, and I'll answer any questions about project 1. So it's a very important day, by the way. Take this one seriously. So that is the plan. And I want to mention one more thing, and that is this is week 2, and 2 is an even number. Why is it important that we're in an even number week? Anyone remember from last week we talked about it?
I believe this is the week we have our first exam.
Yep. So this is the week for your first exam, and you have to take that exam by Sunday. I don't ever recommend waiting until the very last minute to do that. You can take it anytime, but if you wait till the last minute, your internet goes down, you're screwed. So waiting till the last minute's a bad idea. So, but I do recommend taking it after you have done the chapter 3 assignment. Okay, and so the regular kind of the question by question assignments, and also the discussion board assignments,
I know, I just said that. You wanna have-
because chapter 3 is included in exam 2.
Where is it?
Okay, in fact, it'll include chapter 1, 2, and 3.
It's in my purse. Where it always is. It's in the
Any
front.
questions?
You don't wanna split it?
Okay, I'm going to mute
Yeah, I guess.
hearing you. But feel free to unmute yourself if you have questions, but whenever I hear background sound, I mute you guys. But again, feel free to ask questions if you have questions. Any questions at all on the exam or on anything else? And just note, good practice for the exam is the chapter assignments, because I'd say 2/3 of the points and probably more like 5/6 of the exam, or maybe more than that, maybe 6, 7, 8 of the exam, literally come directly from those homework assignments. When the computer just randomly chooses some problems for you, everyone gets a different quiz because, exam, because the computer randomly picks a bunch of problems for you. And most of those problems are literally randomly picked from the assignments, at which when you did the assignment, you had a bunch of randomly picked problems. So it's from the big pool of questions. And then the last couple problems are where you actually have to type things out, more like the discussion post, where you had to type out what your thoughts were on whatever you were doing. Okay.
Are we able to redo the assignments after their due date? And if
Yes.
we do, does it like impact our grade or anything?
Yeah, that's a really good question. And the good news is it's absolutely yes. You can always redo the assignments after the due date. And it will be in what's called review mode, which means that you do the assignments and how you did on each question doesn't ever get recorded. So it has nothing to do with your grade, but it does have
Thank
to do with learning, and learning is important. Yeah, so definitely I recommend redoing the assignments. And a couple more things, kind of differences, is that the exam is timed. So you have 90 minutes to do the exam, and that's strict. After 90 minutes, it closes, you can't do it anymore. So make sure that you practice the assignments and don't spend, a half an hour each question, because you will not make it. Because it's usually around, I think there's like 17 or 18 questions on the exam. Okay, so you have to be able to, do the problems in a reasonable amount of time. So that's a big deal, is that they are timed. Okay, if you happen to have a disability that needs accommodations, then please go to our disability, our Student Accessibility Center, and they will identify your accommodations. They'll let me know, and I'll make sure it happens for you. But if I don't know, then I can't make it for you. So that's the one thing. And again, they're the experts, so they make the decisions, and they let me know. So, and they're really nice people. I'm very happy to talk to you. In fact, I might even have one come today to talk about it a little bit, but we'll see if she can make it. Okay, any other questions? Okay, if there's no questions, I have some questions for you. These should be easy, but you never know. Hopefully you all know what this is. Right? So if I have a coin, okay, and this is a quarter, by the way, and I flip it, and I toss it, and I look, okay, before I look, what's the probability that this coin lands on heads? And I'm not cheating or anything, by the way. It should be very simple. It's not a trick question or anything. Okay. 50%, write it as a fraction, right? As a fraction, because that's really important. So write as a fraction, not a decimal. Yeah, so it's 1/2. Okay. And the reason it's 1/2 is that for this coin, again, should be obvious. One of the sides is a heads, and there are two sides. I think you all know that about coins. There's nothing tricky about that. So the numerator is the 1, because that's how many heads there were. And the denominator is a 2, because that's how many sides there are. Any questions on that idea? So the probability of heads is 1/2. Okay, what if I take a die and I roll the die? What is the probability that that die, and there's a regular non-cheating dice or anything like that, what's the probability the die will land on a 4? Yeah, it's 1 out of 6, because on this die, and hopefully you've seen dice before, there is one side that's a 4, and there are 6 sides of this die, so it's 1 out of 6. Okay, so when you have probability, it's always going to be, you always want to think of it as a fraction. And for that fraction, it's kind of the number of, I like to say, the number of ways that make you win, or the number of ways that makes that happen, over the total number of ways that things could happen. So for the die, there are 6 sides, so 6 ways. Okay, how about, we can get harder. Now I have cards. And if I pick a card, what's the probability this card is a queen? Yeah, so again, and if you don't understand, if you're not familiar with cards, that's okay. But I like to use this because it's nice hands-on, it's very Tahoe-like. There are 4 queens, and there are 52 cards in the deck. And if you didn't know that, you know it now. There's 52 cards here, and that's a standard deck of cards. So 4 out of 52 will be the probability that I pick a queen. Does this seem really easy? Remember, I warned you that probability is hard. So far, this should be really easy. It gets much, much harder. What if I pick, instead of 1 card, what if I don't know, pick 5 cards, and I say, what's the probability that I have a pair of jacks? Okay, I'll be very surprised if you can put the answer in the chat box. Okay, because that's a very difficult question. Okay, but it can be computed, and we'll talk about those kind of computations on how to find these probabilities, because counting, if you have 5 cards, counting all the different ways of getting 5 cards, good luck. Okay, if you tried to list them all, you would not make it. You would run out of electricity in your laptop if using a laptop. That's how much work it would take. You would have no chance. In fact, you'd have to have many, many meals, because it would take hours and hours and hours and hours if you had to do it by hand. So probability does get difficult. Okay, but is it important? What do you think?
Can
Is
I
it
take a
important?
guess to the Jack question?
What's that?
Can I guess the answer to the Jack question? It's probably not right, but it's
You could guess it. Good luck.
okay. I get 5 and 169.
Okay, so probability can never be bigger than 1.
Sorry, 5 divided by 169.
Okay, yeah, you're not even close.
Oh, dang.
Yeah. The division is by, I think, 2.5 million, and then the numerator is way high. It's hard. There's a reason why I didn't just do it. I can't do it the whole thing in my head, by the way. And if you think you can, then you have an amazing head. And people call me a math calculator. So, and we'll see. We'll talk about how to do these kind of things, because we have lots of time. We have some time today. Yeah, so I specifically told you this is not one you're going to be able to compute, because it's way too complicated. Whereas, a single jack, that would be easy, out of 1 card. A pair of jacks out of 5 cards, good luck. And just let you know, I made money doing this. Any guess on how? And not just teaching, by the way. I guess I'm making money technically now, but stock market, I'm talking about cards. Cards don't help in the stock market. Any guess? Okay, so when I turned 21, yeah, gambling. When I turned 21, as you know, I'm a mathematician. I went to the casinos and in my head, I did all of the calculations as it was going while playing blackjack. And I made a lot of money, and then I needed to quit. And you know why I needed to quit? This is a long time ago. Okay, if you don't know, because the mob came and told me they will get tired. They did not get, no, nothing about getting tired of it. They came and they said, I will not be alive if I came back ever again. And you listen to those things because they do kill. In those days, they did kill people. And I didn't want to be one of them. So I did. And then I made money when I got here on the other side is I did consulting work for the casinos to make sure that people like me can't win. So if you think you can use probability right now to win in blackjack, at this point, you're pretty much wrong because they've changed the rules based on some of my guidelines, by the way. So it's all probability. And it's kind of important stuff. Any questions on kind of that general idea of the stuff before we get into the definition? Okay, which I kind of said, but. So here is the formal definition of a probability, and that is the probability of an event A occurring is the number of ways A can occur divided by the total number of things that can occur. So notice divided by means you have a fraction. And the symbol we use for probability, mathematicians are pretty boring. We just use P because that's the first letter of probability. So we always use capital P for probability. So P, and then you do parentheses, and then you write down the letter for the event. In this case, it's just A. You can use whatever letter you want for whatever you're talking about. But people pretty much do alphabetically if it's just general. And that is a number in A divided by the number in the entire set. Okay. So now let's do a little more difficult, not the evil ones yet. Let's suppose I pick 2 cards. Now I want to find out the probability that both cards are king. Any questions on that idea? Okay, so I have a regular deck. I grab 2 cards out of the deck at random. What's the probability that both of these are kings? And the way you do this is the following. You say, okay, 1 out of 169 is a good guess, but it's not right. So let me go through and explain and go through the details. So first, you say, what is the probability that the first is a king? Okay, what's the probability the very first card that I picked was a king? That was easy. Do you remember? How many kings are there? Yeah, there's 4 kings, so it's 4 out of, and there's total of 52 cards. So let me make it pretty, put an equation. And in case you're interested, when I do this stuff, I use Google Docs, and it has a little equation editor. It does most of what I need to do. So we're going to have 4, this is just for the first card, over 52. But now here's the issue. To get 2 kings, it meant the first card was a king. What must the second card be to get 2 kings? Yeah, it must be a king. And if it was this king, I already know that this one, it can't be this card again. You can't get the same card twice if you pick 2 cards. So there are only 3 kings left. So I'm going to put a 3, and there's only 51 cards left. Any questions on that? Okay, now it turns out that if you have two events like this, and you want to find out what the probability of both of them happening, you can use what's called the multiplication principle that says just multiply the two probabilities. First, the probability of the first one happening, and then say, well, let's suppose the first one happened. Now what's the probability of the second one happening? If you know the first one happened. Okay, and now what I can do is I can do 4 over 52 times 3 over 51. And it gives me about 0.0045. That's good enough. Any questions? Any questions on this example? Any questions? Just let you know, when you do the assignments that are computer graded, I recommend carrying more decimals, but because it can't hurt to carry extras. But I'm just kind of shortening it up by just doing a couple of them. Okay, so that's kind of how we got this, and this is the multiplication principle. So it's the probability of A and B is equal to the probability of A times, and the way you read this is the probability of B given A. So let me put this in words. So the probability of A times the probability of B given A. Any questions on the multiplication principle? And then I did it over here. Okay, so now let's suppose you pick 5 cards. Okay, so now I'm going to pick 5 cards. So mix the deck up. Pick 5 cards. And we want to find out what is the probability that you'll get a royal flush. Okay, and again, I don't expect you all to know the rules of poker, but I can tell you what it is. A royal flush means that your cards are ace, king, queen, jack, 10 of the same suit. Not necessarily in that order. It could be king, ace, queen, jack, 10. That's fine of the same suit. Okay, any questions on what a royal flush is? Okay, so we want to find out the probability of a royal flush. Well, first thing, how many royal flushes are there? And this is not supposed to be that hard. Yeah, there's 4, because you can have hearts, spades, clubs, or diamonds. Okay, so ace of hearts, king of hearts, queen of hearts, jack of hearts, 10 of hearts. Ace, king, queen, jack, 10 of hearts. Okay, or the same thing with diamonds, etc. But they all have to be the same. So that's 4 on the top. That's very easy. Now we need to find out how many total poker hands are there, which means how many different hands are there of 5 cards, where order doesn't matter. Okay, and just like with the royal flush, if it is, the different order, that's fine. So order makes no difference in poker. All right, so this is much more difficult. If you think you can do this in your head, think again. So how do you think we might do this?
So I'm gonna take a guess. Maybe you multiply 1 over 52 for drawing 1 card by either 5 or in a decreasing, so like 1 over 52, then 1 in 51 type thing.
Okay,
If
good
that
guess, but not quite. Here's how we're going to do it. We're going to use a calculator. So I'm going to go to the calculator. In fact, I'll just do it this way. It's a little faster. And it's called combinations and permutations. Okay. So combinations and permutations, which is number 5. And what it asks you is what is N, what is R? Okay, N is the total number that you can pick out from. How many can you pick? How many different choices are there to pick from? That's supposed to be easy. Yeah, there's 52. Here's the deck. There's 52 cards in this deck. And R is the number that you're picking. How many we're picking for a poker hand? 5. And I want to let you know if order does not matter, it's C for combinations. If order does matter, it's P for permutations. For poker, order doesn't matter. Having a 10, Jack, Queen, King, Ace is the same as having an Ace, King, Queen, Jack, 10. So I click that, and it gives this to us. And this is what I say, there's no way you could list these numbers because there's more than 2.5 million chances. And this is, you know, I think the second time I'm going to tell you this, and that is the math behind this is not something we do in this class. If you want to learn it, you can always look it up. You could take more math classes, but I'm going to be like hiding all the mathematics under the carpet. So there is mathematics, and it has to do with factorials and all kinds of other stuff. And I'm not going to get involved in that. But what you do need to know is if you need to find out how many ways are there of picking something, a certain number of items out of a larger collection, then this is the calculator to use. If order doesn't matter, it's CNR. If order does matter, it's PNR. So it's 2,598,960. I don't want to have to memorize it, so I'm going to copy and paste it. Okay, and we can do that by going to the scientific calculator and going 4 divided by that number. So is the probability 1.539 about? Is that correct?
Yes, but it's not 1.59. It's about like 0.0000 or 6 zeros. at the end
Right.
of
So I
one.
want to mention, actually, it's not 6 zeros, but we'll get there. I want to mention the probability can never be bigger than 1. If you ever ask for a probability and you end up typing in something that's bigger than 1, think again. Got it? Okay. It's a very common mistake. Sometimes, especially if you're using a smartphone with a calculator, it might not even show this part in your smartphone without you like scrolling it over. Does that make sense? So sometimes it just means you need to scroll because it's, you know, too far to the right and the smartphone's not big enough screen or something. So that is important, or a small laptop. So you got the right idea that you need to have some zeros, but it's not 6 zeros. This 10 to the minus 6 means that we move the decimal over 6 places to the left. The first move puts that decimal right here to the left of the 1, and it doesn't add a 0. The next 5 adds zeros. So it's actually point and then 5 zeros and then 1,539. Does that make sense? So that's 0.123451539. Okay, very, very, very small probability, by the way. Any questions on this example? Okay, now let's do another example. Let's suppose you're taking a test. You're all students. And let's suppose that it's multiple choice. And let's suppose there are 4 choices, A, B, C, or D for every question. And there's 20 questions on the test. Okay, and let's suppose that you didn't study at all and you're clueless. So all you do is you just guess. You just, just guess for part A, number 1, guess for number 2, all the way up to number 20, and you just keep guessing. Find the probability of getting them all correct. Any questions on the question? Any questions? Okay, so this turns out to be not as hard as the poker example. Because if you, let's say you chose part A, let's say you chose A for question 1. Can you choose A for question 2? If it's a multiple choice question test? Hopefully you all know this is just testing. This isn't a math question. Yeah. Yeah, you could choose A for all 20 questions if you want. Whereas when you're doing the poker question, if you had the king of hearts, you can't get another king of hearts. Do you see how that works? So this is what's called with replacement. So you look at the first question, and if that was, say, A was the answer, the second question still has 4 choices, not 3. It doesn't have just 3 left. It has 4 choices. So it's called with replacement. When it's with replacement, it's much easier. So then I can look at the probability of 20 wins or 20 correct. Okay, let's make that a little bigger. And what we can do now is we can look at the probability. Let me make it as an equation. And we find the probability the first is correct. What's the probability that you guess the first one right? It's a multiple choice question with 4 different possibilities. Yeah, it's 1 out of 4. Okay, so the probability of the first right is 1 out of 4. And then times, and again, it doesn't matter if you got the first right or not. What's the probability that the second is right? This is easy. Yeah, 1 out of 4. And the third is right is 1 out of 4. Keep going. I'm going to go dot, dot, dot. Times 1 out of 4. What's an easier way of writing 1 out of 4 times 1 out of 4 times 1 out of 4 times 1 out of 4 and 20 times written out? Yeah, it's just a power. This is equal to 1 out of 4 to the 20th power. And that we can just simply do. So 1 out of 4 to the 20th power. Okay, which is very small, by the way. Now it's going to be 12 zeros before the 9. And there's a probability of getting all 20 right. Notice it's really unlikely, isn't it? So, in other words, make sure you study and practice for the exams, even if they're multiple choice. So there are some multiple choice questions, but most of them aren't. But just guessing, it's better to guess than not guess, but your chances are low of getting them all right. Any questions on that? Okay, and again, this is called with replacement in that case. Okay, so now let me write this one. What's the probability of me winning the lottery if I buy 2 tickets? So I'm going to let you decide. Here's the lottery page, by the way. And which lottery do you want to play with? So Mega Millions, Super Lotto, or Powerball. I'll let you choose. Pick one. For the first one to type it in the chat box, that's what I'll use. Okay, Mega Millions. Okay. By the way, Mega Millions. I just happen to have a ticket. So what's the probability that if I buy a ticket, and I buy two actually, Mega Millions tickets, that I'll win? Okay, and when I say win, I'm being greedy. I want to win the 20 million. Okay, I don't care about the smaller stuff. So here's what I have to do. I have to go and click on it. Have you guys played the lottery before? Anyone played the lottery? Yes or no? Yes, I played the lottery. No, I haven't. Okay. Got some no's, got a yes. Okay, well, I will let you know I played the lottery when the expected value is positive. Okay, and we'll talk about that next week. Okay, so what we need to do is how to play. And here it is, step one. Using a lottery play slip, you can find any lottery retailer, pick 5 numbers between 1 and 70, and 1 mega number between 1 and 25. Okay. So I'm going to copy that and paste it in because it'll be easier to understand that way. And we want to find out the probability of winning. How many different ways are there for me to win if I buy 2 tickets? And the answer is really easy. How many different picks by the lottery officials could happen that would make me win? Yeah, 2, because I bought 2 tickets. So that's 2 in the numerator. Okay, now I need to find out how many different ways there are of picking numbers. Do you see that? So how many ways are there of picking numbers? Well, you have to pick 5 numbers between 1 and 70. So to find out how many ways are there to pick 5 numbers between 1 and 70, I'm going to go back to the combinations and permutations calculator. Now I have 70 numbers to pick from. And as the rule says, I'm picking 5 of them. So n is 5. And if you haven't played the lottery, you would know this. If you have, hopefully you do know this. Order doesn't matter. So if you pick in the same 5 numbers in a different order, that doesn't change anything. So that means NCR, and here we go. So for these 5 numbers, there's 12,103,014 different ways. Any questions on that so far? But then I also have to win the mega number. And this should be easy. How many different choices are there for the mega number? How many different ways are there for me picking the mega number? That's an easy answer. You don't need a calculator. Yeah, 25. Okay, and note for each of the 25 mega numbers, there are, about 12 million-ish of the 5 numbers I could pick. So that means I'm going to multiply by 12. Outside 25. Any questions on that? So now what I can do is go back to the calculator. And I can calculate this out. We have 2 divided by, and now I put that 12 million thing in, and then multiply by 25. And there we are at 6.6-ish times 10 to the negative 9th. So that means there's going to be 8 zeros before the 6. And there's my probability of winning. By the way, notice that these are tenths, hundred thousandths, 10,000, hundred thousands, millionths. And then, so 10 million, 100 million, billionth, or about 66 over a billion chances. So should I, play all, if I play, should I put an offer on some big fancy mansion because I'm going to win? What do you think? Yeah, probably a bad idea because the chance of me winning is really small. Not zero, but really small. So by the way, if this, here's a real ticket, it'd be a very bad idea for you to come in and break through my office door window and, shoot me and then grab my ticket because you probably aren't going to get anything out of it. So it wouldn't be worth it. Any questions at all on this example? Okay, so notice there's all kinds of different things you can find probabilities of. So now we're going to do some more. Okay, so suppose, here's another example. Suppose that 20% of all students taking stats at LTCC, Lake Tahoe Community College, are African Americans. And 40% of all stats students at LTCC are non-STEM majors. If 22% of LTCC stats students are non-STEM majors, stats students non-STEM majors are African American, and you pick a randomly selected African American taking stats, find the probability the student is non-STEM. Okay, and I will let you know, a lot of people have a lot of trouble with these kind of questions. So I want to kind of walk you through the process. And I will let you know in this class, there are a lot of word problems. Okay, where that's what the class is really all about, is to be able to use statistics to come up with solutions or answers to questions that are usually written in full paragraphs. And this is one of those examples. Okay. Okay, so I'm going to go through how to do this problem, but instead of just saying, what's the answer? Let's actually go through each step in the answer. So let me talk about how you look at a problem like this and kind of make it work for you and solve it. Here's the kind of the steps I like to use. The first step I just did, and that is read the question. Hopefully you can all do that. Then the second step I recommend is read the question again, but this time slowly. And every time you see a number, take that number and write it as a probability in symbols. So notice that I read this, suppose 20% of all students taking stats at LTCC are African Americans. So our first number is 20% or 0.2. Any questions on that? Okay. So if I randomly pick a stats student at LTCC, then the probability that that person is African American will be 0.2. Any questions at all on that idea? So now what I'm going to do is I'm going to write that in symbols. So probability, I use P. I'm going to use A for African Americans because it starts with A, sounds good. So P parentheses A, N parentheses. Okay. And then equals 0.2. Are there any questions on how I came up with this first probability? Any questions on that? Okay, so I've only read really this, first line. Now it's time to read the next line. 40% of all stats students at LTCC are non-STEM majors. So I'm going to use the letter N for being a non-STEM major. So I can say P for probability of N, so parentheses and the parentheses, is equal to, and 40% gives you 0.4. Okay. Any questions on that? And I want to remind you, when you turn a percent into a decimal, you take this 40 and you move the decimal place over twice, and that's why it's 0.4. Okay, so if it was 5%, it wouldn't be 0.5, it would be 0.05. You have to move twice. Any questions so far? Okay, then I read the next line. If 22% of stats students, non-STEM majors, are African American. Okay, so now we're saying that of the non-STEM majors, 22% are African American. So here we're given the information that somebody's non-STEM, and the probability that they're African American is 0.22. Any questions on that? So the way I write that is P for probability, parenthesis, and then A for African American, and this little vertical line segment is given that they're non-STEM, N, and then I end the parenthesis, equals, and then 22% becomes 0.22. Any questions on how I came up with this information? Okay, so I want to find the probability the student is non-STEM. Okay, sorry, if you pick a randomly selected African American taking stats, find the probability the student's non-STEM. So I want to find out the student is non-STEM if I know the student is African American. So I can write that as P of N given A equals, that's what I don't know, so I put a parenthesis. Any questions so far? I want to give you a very big warning. And that's that watching me do it is not the same thing as you doing it yourself. Okay, it's much easier to watch me do it than to do it yourself. I like to, my favorite analogy of that is kickboxing. Okay, which I used to do, by the way, when I was younger. It's much easier to watch someone else kickbox than to kickbox yourself. Okay. And I remember we did have one kickboxer, at least they posted in the on the discussion board. And I was one also at the time. And it is much harder to sit and to do it yourself than to watch someone else do it. Trust me. Same thing with coming up with probabilities. It's much easier to watch me do it than to do it yourself. So make sure that even if you totally understand what I'm doing, make sure you practice a lot before you have to take the test. Okay, the next piece is we have two formulas here. Okay, and that the first is the probability of A and B is the probability of A times the probability of B given A. And the second is the probability of A and B is the probability of B times the probability of A given B. Okay, when you have an and, it doesn't matter what you say first, and that's why you can kind of switch the A and B there. Any questions on those formulas? Okay, you can also take this bottom formula. You could divide left and right by probability of B, and that gives you this new formula. Probability of A given B is equal to the probability of A and B divided by the probability of B. Any questions on these formulas? Okay, so now, look at it this way. I know the probability of A and B is the probability of B times the probability of given B. And I can now turn that into A and N in this case. The letters don't matter which letter you use, as long as you kind of follow the formulas correctly. And I can say the probability of A and N is equal to 0.4, because that's the probability of N, times 0.22, because that's the probability of A given N. Any questions on the probability of A and N? Okay, now I can find the probability of N given A by using this formula. That's the probability of A and N divided by the probability of A. Okay, using this formula with different letters, but it's basically the same formula. So then the numerator, probability of A and N, is the 0.4 times 0.22, which I put in the numerator. The denominator, probability of A, okay, is 0.2. And there's my answer. And if you want, you can throw this in the calculator. I'll let you do that by yourselves. Hopefully you know how to put numbers in the calculator. Any questions on this example? Any questions? Okay, hopefully you understand that this does take a lot of effort to read a paragraph like this, come up with what's given in symbols, what's asked for in symbols, and then identify the formulas that you need to use, and then use those formulas. And that's the process in finding probabilities when I call wordy questions, kind of paragraph type questions. Any questions on this? Okay. Hopefully it didn't scare you too much. How we have time? Yeah, I think we can do this. Okay, let's look at a different example. Again, I can come up with probability examples like forever. There's so many. Suppose you roll 2 dice. These are not regular old 6-sided dice, not going to cheat or anything like that. And when I find the probability the sum is a 5. So I'm going to roll them. And I want to find out the probability of the sum is 5. So for example, if that's what I rolled, a 3 and a 2, the sum was a 5. Okay, on the other hand, if that's what I rolled, a 3 and a 6, the sum's not a 5, then the sum would be a 9. Any questions on what the question's asking? Okay, let me give you a minute, see if you can do it. This doesn't use anything too fancy. Okay, might take a minute, but it shouldn't take longer than that. So I'll give you a little bit of time, and it's worth trying, and then I'll do it too. And when you got it, put it in the chat box. Maybe some of you are stuck. I'll do this part for you, which hopefully you all know to do. And that is, it's a fraction. Because probabilities are fractions. And at the end, you can divide and make it a decimal, but usually start with a fraction. Okay, I don't see y'all jumping in, so maybe I'll go through it. So what you want to do is literally kind of look at all the different ways you can get a 5. So for example, I can get a 1 and a 4. So the first is a 1, and then the second must be a 4. The first could be a 2, and the second must be a 3. Okay, and you count, so that's 2 of them. The first could be a 3, and the second must be a 2. That's 3. The first could be a 4, and the second could be a 1. Now I'm at 4. If the first is a 5, it can't be a sum of 5. That's it. There's 4 different ways of getting a sum of 5. Any questions on that? Okay, how many different rolls are there? How many total rolls are there with 2 dice if they're 6-sided? And that'll be my denominator. So how many different rolls are there? And there's a lot, but if you do it mathematically, simple math, by the way, it's actually quite easy. You could count, but it's a lot easier to just say, well, the first die, there's 6 different choices, right? The second die, there's 6 different choices. So for example, for 1, there's 6 choices. For 2, there's 6 choices. For 3, there's 6 choices. So there's 6 groups of 6, or 6 times 6 is 36. You could count, but that would take a long time. It's a lot easier to just say, well, 6 die, 6 times 6 is 36. Any questions? Does that make sense? There's my probability, and I'm done. Oh, ways you get the 5. Well, you know, the first die could be 1, 2, 3, or 1, 2. Oh, did I write 5? It could be it was a 4, sorry. It could be a 1, 2, 3, or 4. And once you know the first die, you don't have choices for the second die. If you want to add to a 5. Okay, and there's the answer. If you want to reduce, you can go to 1/9. If you want to write as a decimal, you can. I'm not going to bother. Any questions at all on that example? Okay, now let me do the next type of example. And that is contingency tables. And these come up a lot. And I'm going to do it by example. I think that's the easiest. Okay, let's suppose that a survey was done. Let's make this a little bigger. A survey was done asking LTCC transfer students where they plan on transferring to and what living situation they will be in when they transfer. And this table shows the results. And when you have a table like this is how you read it. For example, this number 15, for example. Let's go number 9. Let's go number 7, actually. I like the number 7. What that means is 7 of the students are going to go to UNR and live with their parents. Any questions on how you read this table? Any questions on that? Okay, so this is called a contingency table. Okay, so now I have a question, is find the probability that a randomly selected student will go to a UC campus or live in an apartment. Any questions at all on the question? Okay, if you add up all these numbers, you get 246. You can trust me, you can stick it in a calculator and you'll get 246. Any questions so far? Okay, next, and hopefully you're used to this point, there's going to be an important formula. And here's the important formula. And that is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Any questions on that formula? Okay, so the next thing I did is instead of A or B, I used what we're interested in. And we want to find out probability that they'll go to a UC campus or live in an apartment. I'll call that UC, or A for apartment. Sound good? So now I can use a formula and then say that's the probability of UC plus the probability of A, or apartment, minus the probability of UC and apartment. Any questions on this formula? Okay, so now we just figure these things out. So one of these things, one thing to note is that all of these probabilities are going to have the same denominator, 246. Okay, so let's take a look at these. Let's find the probability of UC. Well, to find the probability of UC, I have the UC campus people. There's 33 of them. There's 8 more, and here's 19. So I take 33 plus 8 plus 19, and I divide by 246. Any questions so far? Okay, then I want to find out probability that they are going to live in an apartment. So these are our apartment numbers. I'm going to take 43 plus 33 plus 19 plus 22 and divide by 246. And then it says minus the probability of UC and A. And that's just these 33 students. So it's minus 33 over 246. Any questions on that? And I'm not going to waste your time, but hopefully you know how to put that in a calculator. I'm going to assume you know how to use a calculator to do arithmetic. Sound good? Any questions on that example? Okay, so now a very important definition. So two events A and B are called mutually exclusive if the probability of A and B is equal to 0. Okay. Any questions on the definition there? Okay, it's kind of they can't both happen simultaneously. So are transferring to CSU and living with parents mutually exclusive? So to figure that out, what I'm going to do is do the calculation. Probability of CSU and living with parents. I think I wrote it out already. So here it is. Well, if we go up here, there's 34 students that are going to transfer to CSUs and live with their parents. So 34 is the numerator, 246 is the denominator, and hopefully you don't need a calculator to know that's not 0. 34 over 246 is not 0. And if that's not 0, they're not mutually exclusive. Any questions on that?
When I was reading through the chapter, I was having a hard time distinguishing it from independence, but this example helps out a lot more. Could you
Oh, good.
describe it with something like die or a coin or something? Or a coin
Okay.
flip?
So for example, let's suppose I roll a die. Here's my die. And let's suppose A is the event that the die lands on an even number. And B be the event that the die lands on a 3. Okay, those are mutually exclusive because the probability that you land on an even number and a 3 is 0. That can't happen, right?
Okay, so in a nutshell, mutual exclusivity, if that's how you're supposed to say it, is basically, do the events have overlap or not? And if they have overlap, then they're not mutually exclusive.
Yeah, yeah. In
So,
words,
like-
that's true. The definition is the probability of A and B equals 0, but in words, do they have, if they have overlap, then they're not mutually exclusive. If they don't have overlap, they are mutually exclusive.
Okay, so like the events that a student lived in an apartment and with their parents would be impossible since. they
Right.
can't
So
be
the
two things at
probability
once.
of living in an apartment and with your parents, okay, at least the way this is written would be 0. Okay, in their own apartment and their parents. Let's call it that one.
Okay, makes sense. Thank you.
Yeah. And we'll get to independence next, by the way. So I promise that's next. Okay, good question, though. Good question. Okay, here comes the independence. And again, these are all formulas. Okay, two events A and B are independent if any of the 3 equations are true. So the first is the probability of A and B equals the probability of A times the probability of B. The second is the probability of A given B is equal to the probability of A. The third is the probability of B given A equals the probability of B. And if any of those are true, then they are independent. If any are false, they are dependent. I'm not going to prove this, but it turns out that if one is true, they're all true. If one is false, they're all false. And you can either prove it yourself or you can trust me, you choose. Any questions on the definition before we do some examples? Okay, so are living in an apartment and transferring to UNR independent? Okay, so let's do the calculation. It turns out that the second and third equations are usually easier than the first, because the first actually has 3 probabilities to calculate. There's 3 P's here, whereas the second and third each have only 2. So if you have a choice, usually the second or third are the easier ones. Okay, usually, not always, but usually. So let's find the probability of living in an apartment given that you're transferred to UNR. So if we're given the transfer to UNR, what that means is that we're only looking at the students who are transferring to UNR and finding the probability they're living in an apartment. So of the UNR transfer students, 19 are living in an apartment. Is that clear? Any questions on that? And how many UNR students are there? There's 19 plus 7 plus 15. 19 plus 7 is 26. 26 plus 15 is 41. So we get is 19 over 41. And I pop that in a calculator and I got about 0.463. Okay, on the other hand, if I want to find out the probability that a random student, just a general random student, lives in an apartment, then I take 43 plus 33 plus 19 plus 22, because those are all the apartment students. And I got 117. And as I mentioned, there are 246 total students, and I get 0.475. And hopefully you can see 0.463 and 0.475 are not equal to each other. And if they're not equal, that means living in an apartment and transferring to UNR are dependent events. Any questions on this calculation? There's a lot of calculations in this chapter. Probably the most of any of the chapters where we actually have to do this kind of stuff. Okay, let me give you kind of a more of a general idea of independent and dependent. Let's suppose that we look at the probability. Let's say A is a probability that a student is a person, okay, an adult, has graduated from college, okay, has a degree, college degree, okay. And let's suppose event B is the probability that they make above the median income. Do you think those are dependent or independent? What do you think? So A is the event that they have a college degree, and B is the event that they make above the median income. So what do you think? Are they independent or dependent?
Without further information, I probably couldn't say for sure, but based on the information, I can make a solid guess that they're pretty related, so they're dependent.
Okay, they are definitely dependent. Okay. And hopefully you've done a little reading about college. And hopefully you know that if you look at the first thing, the probability, if you don't know anything about whether they have a degree or not, just the probability that someone has above the median income. What is that probability? You should all know that. What I'm looking for a number. It's part of the definition of median. That's a hint. Yeah, 50%, because 50% are above the median, right? That's the definition of median, right? Okay, on the other hand, if somebody has a college degree, hopefully you know, I mean, some of you know this, and that's why you're in college, is that if you get a college degree, then you have a much higher chance of making better money. Hopefully you know that, right? Okay, it's a higher chance. It doesn't mean you definitely will, but you have a higher chance. So given that someone has a college degree, then you'll have more than a 50% chance of making a median, or that person will have more than a 50% chance that they're making above the median income. So those are not the same. Probability of A given B is not the same thing as the probability of A. Any questions on that? So those are dependent. Okay, let me give you another example. Let's look at the example. Let's suppose that A is the event that the on a given day that there is soccer being played at LTCC, and the probability, and A is the event that our soccer team wins. Got it? And let's suppose that on the same day, let's suppose that there's a team in New York. Let's say New York Community College. I don't know if that exists, but pretend it does. And they have a soccer team. Let's suppose B is the event that their soccer team wins. Okay. And this is just regular season, and we don't play New York, by the way, in regular season. It's too far. Do you think those are independent or dependent? What's your thought? Put in the chat box. Everyone should at least guess. Yeah, those would be independent, because if if Lake Tahoe Community College soccer team wins, does that give you any information about whether the New York team won? They have nothing to do with each other. Does that make sense? They're not in the same state. They don't play in the same league. They're not even close to each other. So they would be completely independent. Okay, and that's kind of the idea of independence and dependence. The formulas are all here. Any questions about independence and dependence? Okay. By the way, are they mutually exclusive? The soccer team in LTCC winning and the soccer team in New York winning, not playing against each other, by the way. Are they mutually exclusive? Okay, I'm a little worried that you already forgot what mutually exclusive is. Okay, they're definitely not mutually exclusive, because mutually exclusive means the probability of A and B. It's over here. Probability of A and B equals 0. Well, is it possible that LTCC soccer team wins and New York soccer team wins? They're not playing against each other. Just playing in their own states. Yeah, it's possible, right? It's a non-zero probability. So they're not mutually exclusive. Do you see that? Because they definitely can both happen. All right. That is everything I need to say about probability. So the secret word is symbols. And the reason I'm using the word symbols as a secret word is that when you have a big word problem, like a whole paragraph that's a probability problem, your first step, after, well, your second step, I guess, is to turn every number in and write it as a probability statement using symbols, P, parenthesis, maybe A, and parenthesis equal a number. So that's a secret word for this week. And don't forget, knowing the secret word isn't enough. You actually have to go in and click on secret word quiz and type the word symbols in it. So don't forget to do that. And then it's easy, you know, it's not the kind of thing where you need partial credit because you should get it right if you watch the webinar. Okay, what I want to do now, if you remember, is talk about project one. So now I'm actually going to go to the course, the Canvas course. And I want to show you some stuff about project one. Let me hit syllabus and show you a few things. First is that project one is due by May 14th. Okay. I want to let you know that that might feel like a very long time from now, right? But you know how time happens. If you just keep waiting to start, it'll go badly for you. Okay, you'll be ready to start today, by the way. And you know, you want to spend some time. This is a big part of the course. And project one is due on May 14th. And the first step I hope you already did, and that is get partners. So best is 3, as I mentioned. You're allowed 2, but 3 is better. And if you go to the project discussion board, and click on that, then you'll see a bunch of people posted about the project and saying, look, I'm looking for a partner. Okay, but what I want to do now is talk about the project. If I scroll down, and you want to make sure you can do this, under projects, then it says you're supposed to collect quantitative data. Okay. Who remembers what quantitative means? Yeah, numbers. So you are going to be literally conducting a survey. So you're going to be conducting a survey. So what you need to do is you need to write down a survey question. And what I recommend doing is asking your partner the survey question, or partners. And if they don't answer with a number, then it will not work. Got it? So do not ask them, what is your favorite color? Because they're not going to say 14. Okay? Or don't ask them, you know, do you plan on, you know, getting a master's degree? Because that's a yes, no question. It's not a number. Does that make sense? So make sure that the answer to the survey question is a number. That's necessary. Okay. If you don't have a survey question that is quantitative, if you have qualitative, it'll be a disaster for you. So that's absolutely important. Click on project one, and I recommend you all do this too. This is all on Canvas. You have all the access to be able to do this. And I want to go through all the different things that you have to do for project one. That's the plan. I'm not going to read every word of it, but think of quantitative investigation. You're going to have to go and perform the investigation and produce a report. Okay, as though you were handing the report to the person paying for your services. Okay. Okay, and it's in theory, in terms of paying. You don't really have to find someone to pay for you, but you have to do that in theory. Okay. So here's what I recommend in terms of the step-by-step procedure for the project. Step one, I already said, get a partner, or better is get partnership of 3. That's step one. Step two is have a conversation with your partners and come up with a study that might be interesting to you all, and a survey question that could be asked of people. Any questions on that step? Okay, so you're going to come up with a survey question, and that survey question again has to be quantitative. And the next step is decide on your client. Okay. Yeah, you're going to decide on the client. So just let you know, if you have to leave, then this is recorded. It will be back on in a couple hours, probably. It'll be on YouTube. Okay, so you have to decide on a client. Okay, and again, you don't have to talk to the client. The client could be President Biden. That's fine, even if you've never met him. I've never met President Biden, but that's fine. It could be the manager of Safeway, or it could be whatever. Okay, but it should be a person who would be interested in learning about the results of your project. Okay, so that's the next step. After you have decided on your client, then decide who your population is. Okay, the population might be, for example, all Lake Tahoe Community College students. It might be all adults in California. Okay, it's going to be people, and it's going to be all of something is the idea. Okay, and that'll really depend on what your study is. Okay, so after deciding on your population, then decide on how are you going to conduct your sample. Okay, just to note, the sample size must be greater than 30. And this is one of those things where this greater than 30 is really important, but you have probably no idea why right now. But trust me, when we get to chapter 7, you'll totally understand why greater than 30 is important. So that needs to happen for a good study. Okay, so your sample size must be greater than 30. You have to decide on your sampling technique. That's your next step. So how are you going to sample the people? And your sample size, let's say, is 31. That's fine. 31 is the minimum, by the way. The population needs to be really large. So large that you couldn't ask everyone. If the population was 35, having a sample size of 31 is stupid because you just ask all 5, and this doesn't work for the project. So your sample size should be large, like, all students in California that are community college students, or maybe all people who live in Tahoe, adults. Just let you know, one more thing is that it must be adults. You're not allowed to survey children. That is against the law. So it's not just against this project requirements, it is against the law to survey children, to just go and ask. Okay. The only children you are allowed to ask is if there is a child, and definition of child, by the way, is under 18. If there is a child who is a college student at your college, you're allowed to survey that child. Okay, if they are a college student, and that's because their parents have actually signed something that says that can happen. So just trust me on that one. But otherwise, absolutely not. You cannot go to a high school and ask a bunch of kids. That's not allowed. Okay, don't even think about it. I don't want to get sued. You don't want to get sued. And I will take off points, by the way. Okay, you have to decide on the sampling technique. Here are your choices. One choice is simple random sampling, and I will let you know This is almost never possible. So almost no one ever chooses this one because it's usually impossible to do it. So almost all of you, probably all of you, will not do this. The other two choices are stratified sampling or cluster sampling. Okay, those are pretty much what everyone's going to be doing. One of those two, either stratified or a cluster. Okay, it is very important. It is very important that you do it correctly. And I have links to what stratified sampling and cluster sampling is in case you forgot. I'll let you read that and make sure you follow the procedures. Okay, so you have to decide how are you going to do your sampling. Okay, your next step that I strongly recommend is to go to the Project One discussion board and type in your proposed project. What is your survey question? What's your population? Who your client is? And how you're going to conduct your survey. And I will look at that and let you know if it works or not. Okay, most of the time it works, but you have to do some refinements. And I'll say, yeah, that'll be good, but maybe you can change your wording a little bit of the question to this, and that'll work it better for quantitative or whatever. So it's not, occasionally I'll say, sorry, that won't work. Try something else. But usually I'll let you know it'll work, but you need to change something slightly. Okay, any questions so far? Okay, the next step will be to conduct your survey. So you conduct your survey, and that means you're going to ask your 31 people or 38 people. There's no reason to ask 150 people. That's just too much work. For this project, it has to be over 30, but you don't get more points if it's 90 versus 31. Okay, maybe you'll do 33 if there's 3 of you and you want to break it evenly and each do 11 or something. That could happen. But there's no reason to spend, a huge amount of time doing, hundreds. The only reason that there is a reason to do a larger sample, and you might like laugh at this one, is if you're doing it for work and your boss wants more people. I've had that a few times. Some people actually do it for their job. And you're welcome to do that as long as it works for our project. You can do that. But you can't do under 31. That's never okay. Okay, so then you do the survey, you conduct your study, and you write down all of the survey question answers. Any questions on that piece? That shouldn't be that hard. Okay, I will let you know if you're going to survey, say you're doing cluster sampling and you're going to survey classrooms. Those are your typical clusters for students, for example. The one thing you should do is get the permission of the instructor. The instructor will almost always say yes when you tell them this is for my stats class. Can I ask students? I do recommend if you're going to be going into a face-to-face class, actually writing down the question a bunch of times on paper and have them write it down, the answer. It's a lot easier than having them answer it vocally and you have to write it down one at a time. It's much easier to hand a bunch of papers to everyone, then pick them up. Okay. The other thing is if you're going to be doing it at a business, let's say your survey had to do with how much people tip at restaurants or something like that. Make sure you talk to the manager and get the manager's okay that you're allowed to ask. Even if you work there, because I don't want anyone losing their job because of my class. So get the manager's permission, and they usually say yes if you tell them what it's for. Okay. Any questions so far? Okay, and by the way, you are allowed to do online. You're allowed to do the survey online. Okay. I will let you know that you typically have a bigger voluntary response bias when you do it online because people tend not to answer survey questions if it's an online question. It's harder to get people to answer than if you walk up to someone and ask them and say, hey, this is for my class, and I really want to pass the class. can you answer my survey question so I could pass? They'll usually say yes. But if it's online, they think it's spam. That typically happens. So just let you know, but you're welcome to do online. Okay, but you just have to use Stratified or Cluster. Okay, so then once you have collected your data, the next thing to do is to put it into the spreadsheet. You must use a spreadsheet. And just a reminder, it's a Google spreadsheet, so I'm going to go to my drive. This is a spreadsheet, and don't forget, you have to go to File. Then you have to make a copy, and only one of you needs to do this. Give it a name, hit make a copy. I'm not going to do this because I already have my copy, but you're going to need your own copy so you can put the data in. It says one Veristat, so it actually defaults to the right spot. Then the first thing you're going to do is you're going to highlight all the numbers that are in it, and you hit the backspace, and that deletes whatever numbers are in it. Okay, then you're going to type your numbers in one at a time. Any questions so far? Okay, and this will give you the information you need. So it gives you the minimum, the mean, the variance. Variance you don't really need, the standard deviation you need, the median, maximum, Q3, and as a sample size. Q1 you need. We don't need any of this confidence level stuff or p-value or any of that. We do need a z-score. Do not use this number that's already in there. You need to put your own number in there. That will help you find outliers. It'll also help you find maybe important numbers that might be important for your project. And then you can get the z-score for that. Okay. Any questions about the spreadsheet? It also will do a histogram. It also, if you go to stats and box plot, it'll give you a box plot. Also, if you go to stats and do stem and leaf, it'll give you stem and leaf. Okay, you need all of that, by the way. Okay. And in your paper, you need to actually copy and paste all the charts into your paper itself. And you need to copy and paste columns C and D into your paper. Okay. So that has to be there. And that, because I'll look at it, and if it's not there, you lose points. Okay, it's not hard to do that. And again, you can get help. And in fact, I see Kyle is here. So Kyle will be happy to help, I believe, right?
Absolutely.
Yeah. So Kyle's, remember, our embedded tutor. There's other tutors too, but Kyle's the one that really knows this class. So he has lots of hours, and he can help and, give you whatever assistance you need. I can help. Posting it in the project discussion board is also another place you can get help in. Okay, any questions so far? Okay, then let me go back to the project. Once you have your statistics and your charts, then you need to interpret them. And I want to let you know the audience is not me. The audience is your client. It's all about the client's needs. The entire paper, throughout your paper, is about what the client can do with the statistics and what the client can do with the chart. What decisions will the client make after seeing what the standard deviation is? What decision will the client make after seeing the first quartile? What decision will the client make after seeing the histogram? Okay, throughout the entire paper, you're going to be writing about that. That's what most of your writing is to the client. Okay, you're also going to write about your sampling technique and bias that will happen. If you think there's no bias, you are wrong. There's always bias in these kind of studies and survey questions. So good luck saying there's no bias, because then you better fully explain why there's no bias, and you won't be able to because it's not possible. Okay, so you're allowed to have bias as long as you explain what that bias is. Any questions on that? Okay, so again, throughout the paper, it's for the client. Okay, you also need to spend an entire paragraph on the standard deviation. That's a main part, at least a paragraph. It's a main part of this particular project. So the standard deviation itself, what does that tell you about the population? What is that, or about the sample? How will the client use that information to make decisions? Okay, the standard deviation, how is that used in the Z-score? And how will that tell you about outliers? And what information, given the information of outliers or not having outliers, what decisions might the client make? Based on standard deviation, that's going to help you either use empirical rule or Chebyshev theorem. Remember, you use empirical rule if you have an approximately normal distribution. The way you're going to see if you have approximately normal distribution is you're going to look at a histogram and or stem and leaf plot and see if it's normal shaped or not, approximately normal shaped. If it is, then you have an approximate normal distribution, and you write about that. And then you can use the empirical rule, and you can talk about how is the client going to get help with that information. On the other hand, let's say you had a very skewed left plot, then you can't use the empirical rule, but you can use Chebyshev's theorem. So you're going to do Chebyshev's theorem, and then you're going to talk about how the client is going to use that information. Okay, any questions on that? And that's all standard deviation stuff. Okay, this is a paper. So it should be written just like you would write a regular paper. There should be an introduction, a body, and a conclusion. Hopefully you're all used to that. And so the introduction, you should talk about what your survey question is and, kind of the main points. And then the body are all the details that I've just been talking about. And then the conclusion is kind of the main points again, but now the conclusion of the main points. Also, you're going to reflect, you're going to think about, well, what would you do from afterwards? What might you do next month or next year for a better study? Okay, how might you do a different sampling technique or a better sampling technique to reduce the bias? Okay, because again, you're identifying bias, so how could you reduce that bias? And that's all in theory, but bias can always be reduced. Okay, any questions on kind of that conclusion? Okay, and just some notes, a couple. One is after writing your paper, okay, what you're going to do with your partners, and you might use a Google Doc or Word doc or some document thing. What I strongly recommend is have it done early enough so that you can send it to me, you can email it to me, and I will give you suggestions to improve. Okay, and if you don't email it to me, then you won't know of my suggestions to improve, and good luck getting an A, because if you don't hear my suggestions, you're just going to lose the points that you would have lost. Whereas if you hear my suggestions, then you can fix a bunch of stuff that might have gone wrong and improve on it so that you can get a better grade. And the very last date to send me your your project draft is Thursday at 8 a.m. before it's due. Okay, and again, if I go to syllabus, then that would be, it's due on Sunday, March 14th, subtract 3 days would be May 14th, subtract 3 days, that would be May 11th. Okay, and that would be May 11th at 8 a.m. But I read it on a first come, first read basis. So if you send it to me Wednesday morning or Tuesday, then you'll get it back sooner and you'll have more time to work on the issues. Any questions on that? So that's kind of how the timeline works. So in the timeline, I like to go backwards I would recommend like having your goal of May 13th to have it done. It's always, I never want to have to wait till the last day if you don't have to. And I mean, whether it's May 13th or 14th at this point, if I told you it was due May 13th, no one would be complaining right now because that's a long time from now. So pretend it's due May 13th. And that way, if something goes really badly wrong, like you lose your internet, you still have another day to return it in. Do you see how that works? And I would recommend maybe that Tuesday to have as your timeline to send me a draft. Do you see how that works? And that way, if something goes wrong, you can do an extra day. Okay. And then how long will it take you to write the paper? That might take a couple weeks to write the paper. So let's go back there. Might take, probably won't take more than a few days, maybe 5 days to do the survey, maybe 1 day, depending on your survey. Okay. And it might take you a few days to fix your the issues that there might be after you have posted your idea on the Project One discussion board. So I would set the timeline that way and kind of go backwards in time and say that's when I need to have it done. So start working on it now is the idea. Meet with your partners in the next few days to get ideas on what your project should be. Any questions at all on project? Any questions? Okay, and again, I'm here to answer questions. And you can ask during next week's webinar too. Again, we have several weeks before it's due, but don't wait till the last minute, please. It won't go well for you. Any questions? Okay, it's 1:42, and that's about when I usually end around 1:40-ish. So we're about there. So I think I'm going to oh, wait, just a minute. Oh, Beth is here. Let me introduce Beth.
Hi, everyone. My name is Beth. I don't know if you.
Wait, just a minute, Beth. Let me do. Actually, no. Let me introduce you. This is Beth Marinelli Laster, and she works for the Student Accessibility Services, and is definitely available to help out if you have any needs. So, Beth, why don't you explain and now introduce yourself?
Sure. Hi, my name is Beth. I will explain really briefly because I know you guys are just about wrapping up. But what we do, I put our website and my email in the chat. And what we do at Student Accessibility Services is we make sure that if you have any kind of disability, whether it's something like attention deficit disorder, it could be depression or anxiety, a physical disability, a learning disability, anything like that, we are here to help make sure that everything is accessible for you. So depending on their disability, some students are allowed to have extra time for exams. We have reading software that helps students who might have challenges with that. So anyway, all kinds of help. If you have ever had something like an IEP in high school, you would definitely want to get in touch with me because that means you've already gotten disability services. So we want to make sure you can continue that during college. Or if you've ever had any kind of diagnosis, definitely get in touch and we will talk about how we can help you. Everything that we do is completely private and confidential. The only person that I would communicate with, and this is only with your permission, would be your instructor, like to let Larry know, like, hey, Larry, this person gets extra time on their exams. But that would be it. And again, that would be with your permission. So I hope to hear from some of you.
Okay, great. And I just want to let you know, those of you who are watching this as a recorded webinar on YouTube, it is on the syllabus because you don't see the chat. It is on the syllabus, and on the syllabus, it has all the information. It has a link to student accessibility services. It has a link to the email. It also has a phone number to call, whatever works for you, right, Beth?
Yep. Thank you. Thanks, Larry. And thank you, class.
Yeah, and that's great. That's great. Thanks a lot, Beth, for showing up. And, and again, we're here for you to help. That's what it's all about.
All right. Thank you. Thanks, everyone. Have a good day.
Okay, great. And I'm going to stop the recording.